SR Parser. SR Parser is an example of bottom-up parser. Here S stands for simple, R stands for right to left derivation. That means that it would complete the right subtree first, then it would move to the left subtree while deriving or parsing any tokens. And 1 here states that it has one look ahead. That means that it would only parse one token at a time. Now let's take an example of a grammar and construct an SLR parsing table for this particular grammar. The steps are just completely same for LR and SLR. The main difference is only in the creation of parsing table that I'll tell you. That's the main difference. I'll tell you at the end, and let's construct a parsing table for this particular grammar and understand how to do it step by step. The first step is to create the augmented grammar. Creating an augmented grammar means to add this production here. On adding this production to our own grammar means that we have augmented our grammar. Second step is to create the canonical diagram of our augmented grammar. You can see that we have created a canonical diagram of our augmented grammar. You can see that there are different states. Total we have 4 states. This is our grammar. On reading A, it shifts to this particular state, that is I1. On reading small a, it would shift to I2 because it has successfully passed this particular variable. Similarly, you can see that because we have a capital variable just after the dot, we have to write the production of that particular variable. That's why we have written this particular production here, because capital A was just on the right hand side of the dot. On reading B, it shifts to this particular state, and this particular state can be called as a reduced state because it has completely read terminal B. Similarly, this state is also reduced because it has completely read the capital variable A. This is not a reduced state because it has no reduced elements. So what we have to do is we have to shift this particular state on reading A. On reading A, it would shift to this particular state where you can see that small a and capital A is successfully being read. Since it is successfully being read, we can say that this I4 is a reduced state. Now moving on to this production and this production. This production can go to this own state. This production can go to this own state in order to achieve this. And this production can go to this state in order to read small b. I'll repeat this sentence again. This production was added because capital letter A was just to the right hand side of dot. Because we have added this particular production, it is our responsibility to reduce that. In order to reduce that, we have to shift that particular variable to small a terminal. On reducing that, it would again reach the same state, that is I2. Now this production, which is dot B, we have to reduce it. In order to reduce it, we would move to I3 state. On reducing to I3 state, we can say that this production is also completely parsed. This is how we create a canonical diagram for our augmented grammar. This was our canonical collection. Now we would move to the third step, which is to create a parse table for this particular canonical diagram. So this is our parse table. It contains two sections, action and go to. In action, we mention our terminals, and in go to, we mention our variables. So what are our terminals? The terminals are small a, small b, and variables are capital A. That's why we have written it in go to. Now the main catch or main difference between LR and SLR is that in SR we write the reduce only in the follow. Let me repeat it. We write the reduce only in the follow of the variable. Now let's take the example and understand how to create this particular table. You can see that I0 on reading A is moving to this particular state I2, right? So what kind of move this is? This is shift move. On reading I0 on reading A is shifting to I2. That's why we have written S2. If I0 on reading A shifted to I3, then we would say S3. Okay, got the point. So now you can see that I0 on reading B is moving to the state I3. That's why it is S3. I1 on reading dollar is getting accepted. That's why we have written accept here. I2 on reading small a is moving again back to same state, and the number of state, what is the number of the state? Second state. That's why it is S2. Similarly, I2 on reading small b is moving to state I3. Because it is moving to state 3, the term that we would write here is S3. Now you can see that I3 is getting reduced. I3 is getting reduced. So what we have to do is we have to find the follow. We have to find the follow of A. Okay, whatever variable that is on the left hand side, we have to find the follow. So follow of A is $. Since the follow of A is $, so this particular production will be written here. Why R2 is written here? Because this was our first production, this is our second production. This is a second production that is being reduced. That's why R2 is written here. Similarly, I4 is also a reduced state. Here you can see that this is completely reduced. So what we have to do is we have to find the follow of this particular variable. We already found the follow of A, that was $. So we have to write the reduced move in follow in dollar. And why we have written 1? Because this was our first production. This was our first production. That's why we have written 1 over here. If it was our third production, if this was our third production, then we would have written R3. Okay, you got the point. Since it is the first production, we are writing here R1. Now let's move to the goto column. In goto column, you can see that I0 on reading A is moving to state I1 or 1 state. That's why we have written 1 over here. Similarly, I2 on reading capital A is moving to 4th state. That's why we have written 4 over here. I hope this parsing table was clear to you. Now let's discuss few important points that we need to remember for SR. The number of states for LR and SLR are same. The number of shift entries that we have for LR and SLR are always same. If LR0 grammar is SLR, means that we can say that every LR0 grammar is SLR, but not all SLR is LR. SLR does not has reduce conflict, means that you can never have reduce conflict. This is a Venn diagram that illustrates the power of both the parser. Here we can see that SLR is more powerful than LR parser, and every LR is SLR because LR is subset of SR or SLR. I hope all the points were clear to you, and if you have any doubts, you can comment down below. Thank you.